Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In 114, video tutorial 114, we exported our 4 images, our dependent image and our 3 independent images to our folder to be used in QGIS. And we also exported our table, our random points table, random points point layers file with where we extracted the 4 layers, raster layers data for each point. So that table has X amount of random points or locations, and then we extracted the 4 raster layers, the values of each of those to those points, and we exported that as well for work. And then we moved it into QGIS, and we started playing around with the rasters and the point layer in QGIS. So in this particular video tutorial, I'm going to continue with the work in QGIS. And remember, we ended up with a points layer file that includes the amount of random layers that we've created, and then for each of those points we have an ndvi value, an elevation value, a rain value, and a temperature value, along with each x and y coordinate. Okay, so that's what we created in Earth Engine when we created the random points. We just exported that file. So that's how it looks. As I said, it's just in point layers format. You can see each of these points, and if we overlay it with our raster file, you'll see it's pretty much the same thing. It looks a little bit different because it's 2 different formats, but the values is exactly the same. Okay, so now we've got this. Okay, and as I said, we've played a little bit around in the previous video tutorial. We looked at the attribute correlation, we looked at the multiple regression, and we just quickly did the trend surface analysis. So we played around with that 3 functionalities within QGIS, which is obviously very, very useful. So that's important to be able to do. And the trend surface one will, if we have time, we'll go a little bit more in depth because that's quite a very, very useful functionality to use when you analyze your region of interest in terms of features. In this case, we're looking at ndvi, meaning normalized difference vegetation index. Okay, so that is what. So in this video tutorial, what I want to look at is interpolation, our methods of interpolation. Now, I'm not going to go into what interpolation is per se, but in general, it is the estimation of unknown locations, or the estimation of the value for unknown location based on the value of the known value of locations. Meaning, if I have a location, let's call it location X, and I have an ndvi value for location X, I know that at location X, let's say the ndvi value is 0.6. Okay, then within a certain or a distance away, whatever that distance is, there's location Y. But we don't know the ndvi value for location Y. So that's an unknown, that's a known location, but with an unknown value. Then what we're trying to do with interpolation, we're trying to estimate the unknown value for that location based on the known value for the known location. Meaning we're trying to estimate the ndvi value of point Y based on the ndvi value at point X. And the distance obviously is determining factor. We used to work in mining, where they did exploration and they did interpolation to try to estimate where deposits of X, Y, and Z is based on known deposits of X, Y, and Z. So that's interpolation. Now within QGIS, you have various different interpolation methods or techniques. Okay, so the one that I use quite a bit is called Smart-Map. Okay, and it's a plugin. Okay, it's a plugin. Let me just quickly stop here. It's a plugin. There is others that we can quickly work around, but that's what we're going to. So you go to plugin, you manage and install plugins. Okay, wait till it's up and running. And we're going to go, and you go all, and you go Smart Map. There it is. It's already installed, so I'm not going to install it. Interpolation using ordinary kriging and machine learning, support vector machine, etc., etc., etc. There's all the tutti frutti that you can read yourself. Okay, so quite a nice looking, quite a nice plug-in to work with. A couple of ins and outs that you will learn, but not too bad. It's something that you can work. I'm not going to install it because I've already installed it. Okay, so there it sits. It sits on my dashboard. So I'm going to use this plugin to generate interpolation, meaning to determine or to estimate the unknown values of known locations based on the known locations of based on the known values of known locations. Okay, so let's give it a go. So I'm going to click on this. Now again, I could not have done this if it wasn't for Earth Engine. Okay, so remember, not that we are forgetting about Earth Engine or we are not thinking about it, but this is just interpolation techniques that I'm using in QGIS, which I found much easier, and I'm more comfortable doing this here than in Earth Engine. Okay, well, I'm not sure whether you can do this in Earth Engine, but anyway, we've generated this from Earth Engine. So again, our beginning. Okay, so let's give it a go. So let's click on it, left click, and there it is. Okay, so there's the folder that it's going to save the data in. Okay, so I'm going to just change that folder to the one that I'm currently working in. Okay, so I'm just going to create another file here, new, on a file, and I'm going to just say Smart Map 1. Okay, because it doesn't like to override. So if I have already done something, I can't use the same folder for an update. It's going to not allow me. So every time you run this, you have to do it in a new folder. Okay, so that's important. When you run it for a second or third time and it gives you stories, it tells you it can't do it, or blah, 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 blah. Just remember that every time you run it, it needs a new folder. Or you have to go and delete what's already in your folder that you generated, delete that stuff, and then run it again. But my suggestion is just create folders. So the next time I run it, I'm just going to make this a 2, and then I'm going to make it a 3, etc., etc., etc. Okay, so we're going to select our ndvi RP, this one here. Remember, which is our file that we've generated in Earth Engine. We extracted all the values to that random points, and then we just via CSV brought it into my QGIS, and I converted that CSV into a points layer. Okay, so there it is. The value that I'm going to work with is ndvi, because that's what we're interested in interpolating, but you can choose anyone. I preferably keep that limit outliers highlighted. Then there's other options you can choose, but I just keep it as export raster because I want to display it. You can export it as points or shapefile, but I just prefer to work it with raster. Again, raster is for visualization. Okay, so I want to present it for visualization purposes. But you're welcome to choose the others as well. Okay, you're welcome to choose these others as well. Then once I'm happy with this, before I do any of the other functions of this particular plugin, I'm going to say import. Okay, so make sure your folder is correctly specified, that you select export raster, that you have the correct input layer. You'll see it automatically updates the coordinate referencing system. The Z value is the one that I'm looking at, and eliminate outliers. I'm happy with that, and I press import. It's going to take a bit of a time. Okay, and there it is. Okay, there it sits. Okay, so it is, remember, that's a huge amount of numbers, so it may take a bit of time. Okay, so just be patient. Just be patient. It might, as I said, take a bit of time to upload. Okay, so once I've done that, now we get to the grid. Okay, so here's the grid. There's my Moran I for auto spatial correlation already calculated, which is very high and stuff. So that's it, and that is just my region of interest, ndvi values plotted in this particular program. Okay, a couple of things that we need to remember here. Okay, a couple of things that we need to remember here. Select your outline. Okay, and I'm going to choose my normal outline as per the shapefile. Okay, for my boundary shapefile for my region of interest, and I'm just saying define. It should give you a little blue text, right? Okay, so that's the one. Another important thing is this pixel size. I had huge problems in that the thing just didn't want to work, and then I realized it's because of the pixel size. Okay, so because it's a couple of thousand points, because of my region of interest is quite big, okay, I'm gonna have to increase my pixel size. Now this is again something that you can play around with, but just remember that it is very sensitive to the pixel size. Okay, so start from a high value and you can work your way down to something which is manageable. But that's your second thing that you have to be mindful. Okay, so the first thing that you have to be mindful is the folder. Every time it needs a new folder. And the second thing that you need to be mindful is the pixel size. Okay, so I'm going to go 100. I'm going to go with this pixel size of 100. Now that's quite big pixel sizes, but as I said, you prefer this thing to run than to hang. In fact, I think maybe we can make it even bigger. I don't want this thing to hang, so let's make it 500 and 500. We can always, it's just to show you what it does, rather to be exact. Okay, so I don't want to do all this stuff and then the thing bombs out. But yeah, I think maybe 500 is too big, but let's keep it. But yeah, please play around with your pixel. That 10 pixel size was way, I think something like, I think it was 50 or 60 if my memory serves me correct. So maybe let's make it 100 with the optimum level. Okay, so that's now important. Next one, I'm going to go to interpolation. Now I'm going to leave all these values the same. I'm not going to do anything here. Minimum distance, lag. I'm not going to do this. I'm going to just calculate. So here it will calculate a variogram. Okay, it will take a bit of time, but it will calculate a variogram. While it's calculating the variogram, oh yeah, well, there's the variogram. See below is distance in meters. You see why it was important for us to convert it into meters? Otherwise, this would be equivalent distance, what is it, decimal or whatever it's called, and which makes absolutely no sense. So it's important that you convert it into coordinate reference system that's based on meters. Okay, so it's 10,000 meters, which is 10 kilometers, 20 kilometers, 30 kilometers, 40, 50, 60, 70 kilometers. Okay, now to understand this, I'm not going to go through all the detail of it, but there's an article here, and you can just search for this article, which talks about variograms. Okay, so basically that's the point there. So up to this point from the nugget, up to this sill point, this range, up to there, there's differences within the variables based on range. But from this point onwards, distance is irrelevant in terms of the value of the points, or the value of the ndvi in this case. So it's short distance, there is differences in the ndvi, but as the range continues, the difference becomes almost negligible. Okay, anyway, you can read through this, but this is basically what it uses. There's a nice article, and let's just search for it. There's a nice number of articles based on this. So you've got the range, which is that point from 0 to that value. So in our case, our range is up to that point is about 15 kilometers. So there's our cell there. That's our cell. That's our range, and there's our nugget. So our nugget, etc. You can go and read up on that a little bit. Okay, but as I said, it's fundamental to kriging. Fundamental to kriging. Okay, so we can use different models. You see, there's a linear model. Okay, so we calculate it now. Again, I'm mindful of this thing is not very stable. You see, there's it now. It changes quite a bit. Now it's there. It's roughly the same. So linear. See, this program is not very stable, especially when we work with such large numbers. So I'm mindful of not playing too much with it because it may just bomb out. I don't want this to do. So let's keep with linear to still. Okay, so let's keep calculating again. You'll see the other values I'm leaving out, but that's up to you to play around with. Okay, just be mindful that if you want to play around with, use as small as possible data set. Okay, so once we've done this, we should actually calculate a kriging, but I'm not going to do this because, again, it will bomb out. It's just too big. It will take too much time. It will take like an hour and a half for this kriging to be finished. So if I had a small sample size or small number of random points, I would have used the kriging, but I'm not going to do this. Okay, so I'm going to stick with my diagram. I'm going to stick to the method. I'm not going to do the kriging, and I'm going to go straight to my interpolation map. And here I just press, you see, I'll keep all my values the same. I'm not changing any of these default values, although that's totally up to you. And I simply press interpolate. Okay, now let's hope the thing doesn't bomb out. It has this knack to bomb out. So let's see if it interpolates. Okay, so let's see. See, it's not responding, but let's give it a time. There's two reasons why it struggles sometimes. One is that you use the same folder, and second is that the grid size or the cell size are too small. So let's hope this will work. Okay, it normally displays the interpolation map here at the bottom. It's again one of those things which is a bit weird. It doesn't display it where you want to display. Normally just display at the bottom. So normally when it says not responding like here, normally it has bombed out. Normally it has bombed out. Let's give it another couple of seconds, see what happens. But I'm almost convinced that it is now bombed out again. The problem is that you have to restart QGIS in totality if it bombs out. That's what I'm saying. This is a beautiful plugin, but it's not very stable. It likes to bomb out. So it is one of those that you have to be very patient. So again, one of two things, most probably it is the cell sizes. Okay, so it's not supposed to take this long. It has bombed up. Yep. Beautiful. Okay, so we will have to close the whole thing and start over. Let me quickly pause here while I... Okay, now I've restarted my QGIS, just to show you that these are not pre-planned. I'm doing it as we go along. Okay, so let's try again. Hopefully this time it won't bomb out. So we go to Smart-Map. I have now created a second folder. You'll see there, because I can't use the initial folder except if I delete everything, because it can't overwrite. That's the important part. Okay, so select the second folder. Again, I select our one, we select the ndvi, and we press import. Let's see if it imports. Okay, so let's see. We'll just wait for it to update. Okay, import attribute table. Okay, so there we go. So good. Let's now make it big. 500. I don't want to have to redo this. So 500. We can outline. Would be our region of interest outline. I'm going to keep all the rest the same. I'm going to go interpolation. We're going to calculate the diagram. We have to do that, so please keep that in mind. It's one of those things that we have to do because it has to identify all these other values. Okay, there's our diagram. You see now it has created all these other variables, so we have to do it. And I'm going to go straight. I'm not going to play around now. I'm going to straight to interpolate. So let's see. Let's hope it now interpolates. There we go. It's interpolating. At least we've got this. Yep, it's doing it. Yoo-hoo! There we go. There we go. Okay. So this is our bugger. This thing here. Okay. It all hinges on this damn thing. Okay. So bear this in mind. Okay. So there's our interpolation. I can't make this. Let's see if I can't make this bigger. Nope. It doesn't want to go. This said it's a very unstable little program. Beautiful program, but unstable. Okay. So this is now the interpolation. So it's projecting the ndvi values of my region of interest, or it's estimating or projecting the unknown ndvi values based on known ndvi values for my region of interest. Okay, so let me minimize it, and there it sits. As I said, it puts it there at the bottom. Okay, so let's overlay. So let's make this the same color scheme as the original one. So we're going to go linear, and we're going to go that. We're going to go classified, continuous. We're going to say apply, and there it is. So that's the kriging. Let's compare it with the actual, and there's the actual. Nope, not the actual in raster format. Why is it not? Okay, let me just quickly get all this. You see, that's a problem if you don't save regularly. Save. So that's the kriged value, and that's the actual ndvi values. Okay, you can see the actual ndvi values from -0. This is from 0.16 to 0.64. That's to 0.48. But the important part is the trends are, or the, let me say the dynamics or the characteristics of the ndvi value is similar. So let's quickly have a look. If I select the ndvi, okay, it's not going to work now. Anyway, I wanted to just get the ndvi values of a location, but let's park that for now. But that's the idea of the kriging. Now, that's my method 1. Okay, my kriging method 1. So I can, for example, now say, okay, that let's use a spherical method. Okay, so I'm going to recalculate the diagram. At some point, not respond. Okay, there's the diagram now recalculated. Let's just make sure it's recalculated. So it recalculates and then it updates all these values. Okay, so I've calculated now. Now my problem is that we have to go to data and go and select, and I need to generate a third folder, Smart-Map 3, because it will not override, and so you'll have problems. So we select that one, set grid, so that we keep the 500, so that's all the same. We use the spherical one, and we say interpolate. Let's hope it interpolates. Yep, it will interpolate, hopefully. Yep, it's interpolating. It's interpolating. Okay, so there is that specific one. So let's put that up there. Let's properties and classify it on the same basis. Press OK. Now we can compare the two. You can see this. That's the one with the spherical method model, and that's the one with the linear with the linear to cell method. Okay, so there's two methods. I must say, I think the spherical one looks a little bit more accurate when it compare, or reliable when we compare it to the actual than the other method. And so we can do the, okay, let me save there. Now if we go to the actual folders, you'll see there's the folders. If I open the Smart Map, you'll see there is the different things. It saves it. There's a CSV file. There's two CSV files. There's a kriging map. There's the kriging map that we calculated. So it saves all of these things. Okay, it doesn't work like that. There's another. Okay, it doesn't work. That's the files. It saves it. Now, if I open, you'll see it says one grade map. If I go to Smart Map 2, okay, it says the same thing. And so it doesn't override. And that's why we have to create different folders all the time, because it doesn't override. So that's something you just need to bear in mind. So there's a two that you can. There's clearly a difference. So so that's important to understand. But nonetheless, it's a nice interpretation method. If you have a known quantity of locations that have values and you want to predict for your whole region of interest, you can use the kriging method. And the smart, where we go. This Smart Map is a very useful tool once you start understanding the ins and outs. So let's quickly go look at the Guyson as well. And we're gonna, it will automatically recalculate. That's why it's waiting a bit. Okay, so let's you see the numbers have now changed. Again, we have to go back to data. Okay, at some point. Okay, we go to data, Smart Map. We're going to now create our fourth folder. So every time you want to run it, Smart Map, every time you run it, you have to generate a folder. Because as I said, it doesn't like to override. Let's leave it all. The rest, as I said, is actually the same. Interpolation. We're going to calculate the variogram based on the Gaussian model. And once we're happy with that, then we simply, now again, you're welcome to play around with these ones. Use standard errors. So there's options that you can play around with. I'm just doing the basics now just to explain to you that we are estimating, because unknown locations, the value, the ndvi value for the unknown ndvi value for my region of interest, and then it is calculated as well. It comes there. Let's move that up again. You'll see the names are all the same. That's why, so it doesn't like to override. And that's why you have to create folders the whole time. So we say apply, and there it is. Let's have see how that looks. So that looks like that. That is the, was it just the, and then there's the other one there. Yeah, so there's all three of them. I'm just going to save it. There's the three thing. Now that's based on using the Smart Map. Okay, that's by using the Smart Map plugin. Save parameters. If you look there, there's the X and Y coordinates, and that's the predicted value. And it's done that for 25,000 points that it's done it. So that's a lot. So it has an X and Y, and it's got a predicted value. And then it converts this into a raster file, as what we have set, exported to as a raster. Now, let's see. If I go to cross-validation, I want to press my kriging. You see the kriging will take, as I said, it will take a lot of time. So if you don't need to do it, don't worry about it, because this will take long time. Because it's what today we said, 25,000 points. So that's why it's going to take a hell of a lot of time. So ignore this. If you have just a few ones, you can try it, but there's no need to do this. Okay. The important part is to select, let's say, a linear. Have a look at these numbers. If we select linear now, you'll see these numbers should change at some point. There we see these numbers have changed. So there's 0.005. Let's change it to Gaussian. You'll see it will change. So keep in mind on those values. Focus on those values. So there it has changed. Okay. So every time it's the model, you will change. But you can also manually amend these values at some point. It's not responding. That's a problem. Okay, there we go. You can, nope, it doesn't. It's going to bomb out. You see, it's going to bomb out, not responding. So let's leave it. But again, you should be able to play around with this. Now, you see, that's the one that you're interested, the one with the biggest R square. That's ideally. So play around with these models and values until you get as high as R square as possible. And that's the method that you will interpolate. Okay, so it's gonna hana now with us because it's trying to figure out what must it do. But again, unfortunately, it has bombed out. We'll have to restart eViews. Oh no, there we go. Okay, you see there is the value sense. You can see there now. Let's save here. It just took a bit of time. So let's see if we go. Now, what is these values? These are the values as it contained in this article, which is your range, your nugget, and your cell. So those are three important variables. You see, the range is the kilometers until you reach the cell. Your nugget is from where you start off. So bear in mind, those are the numbers that we're working with. And you'll see in the model, you'll see as you change these numbers, these things change. You'll see now you've got something totally different. And so therefore the interpolation will be very, very different. You'll see the RF is infinite. You can't determine it. So I wouldn't play around with these too much. I would keep it as it is, but that's up to you to determine. So a nice little, yeah, so there's management zones that you can play around, variables to generate, top management, so play around with this. Interpolation, you can go and machine learning, ordinary kriging, which we've used. You can do machine learning, scores. So there's some things you can do there as well. I haven't personally used machine learning. Let's see. I don't know whether it's going to bomb out. Let's look. But I'm going to have to go make a number 5 here. So let's just play it. If it bombs out, it's anyway. I want to conclude this video tutorial. So Smart-Map 5. So nothing gained, nothing lost. So let's change it. Management zones, interpolation. Covariates will be in the attribute table. Cross validation, I'm not going to do this. ndvi neighbor 16. I'm going to leave it as it. We're going to say interpolate. Let's see what it does. Okay, that's machine learning. Let's see what the results are. Now, just as a sideshow, if you don't want to use this plugin, I don't want to honor now while it's working now. Let's see. There we go. There we go. Okay. So let's move. So this is now a different methodology. You can see this uses machine learning, SVM. So let's properties. Let's go and classify this as well. Apply. Let's see how that looks like. You know, this looks very different, huh? It doesn't look as realistic. Especially this one looks very realistic. This one doesn't look. But again, I think one can play around with it. One can definitely play around with it, the weights, the neighbors, and these things. Selection of variables. I'm not going to go with that one. Let's. Okay. I'm not going to play weight. Let's add a co-variable. Not sure what's happening now. It's also a bit new to me, this machine learning part. Selection of co-variables. Let's see what this thing now generates. Applying contour area. It's doing a hell of a lot of calculations. It's created something new. You see, it doesn't load it because I forgot to put a new data set here. Observed value, actual value, observed value, actual value. Anyway, anywho, one can play around with this now. Yeah. We can play around with this now, etc. But it's fundamentally, it's a neat little plugin. Very nice to use if you have point layers. Point layers. Okay, that's the key thing. If you have those spatial points, whether it's random or non-random, it doesn't really matter in this case, but you need those points and with the data, obviously. And that's generated in Earth Engine. So something neat, something interesting, something that one can work with. So that's a lot of fun. Okay, just by the way, why this is on red? Because it's eliminate outliers. Okay, so you'll see these are big values. So that's why it will eliminate these big values. See, there's another one over 0. So all the values about 0.5, they assume outliers, and therefore it will delete those values. Anyway, if you were wondering. So important, remember to, every time you want to run it, change the folder. Make your grid sizable. You can always work down on it, otherwise it will bomb out. Interpolation, ordinary kriging or machine learning, don't worry about cross validation. That's not important. If you can run it, if your capacity with the system or the plugin will run it, fine, but otherwise leave it and then just interpolate, and then you can compare the two. So that's a nice little fun activity to do in QGIS, and that's to do interpolation using the Smart-Map tool, which is a plugin with QGIS. It works in spatial layers, okay, spatial point layers, and yeah, interesting stuff. Okay, by the way, just there's some interpolation methods within QGIS. For example, if you go interpolation here, there's a thin one, there's IW one there. And if you go into white box, let's just do interpolation. Interpolation. You go there by GIS analysis tool in white box. There's again an LDW, there's a nearest neighborhood, and there's a radial basic function interpolation. Okay, so there's some other interpolation methods that you can do there. I found this natural neighborhood interpolation quite useful. Okay, so point vectors you select, files you select, grid size you select, you make it 30 raster base, and you just run. Okay, so there's others, but I prefer to use Smart-Map. That gives the best results. That gives the most reliable, most accurate results compared to the interpolation methods within QGIS. So that's something I can definitely recommend to use, is Smart-Map. Okay, so with that said, let's conclude this video tutorial. It was great having you on board. Thank you very much again. For those of you that subscribe, share, and like the video, thank you so much. For the rest of you, please come and press those buttons. It costs you nothing. It's free, and then welcome to the ride. Welcome to the journey in remote sensing. And yeah, what are you waiting for? Press those buttons. And with that, I'll see you on the other side.